Hi everyone. So in the last class we were discussing about torque on a current carrying loop when it is placed in a magnetic field. So where the aerial vector n vector is perpendicular to the field. So here n is not perpendicular to the field. So here we will discuss it as two sections. First one we have to show that force acting, the net force acting on it is equal to 0. Then we will move on to the torque section. Okay. So first of all, you have to understand one thing. You just note that. So here everything is pretty same that we have discussed as we have discussed in the previous video. I mean previous case. So here n vector is not perpendicular to the magnetic field vector. So here there is an angle theta which makes with the magnetic field. So I think you have got it. So now we are going to move on. Okay. So again the same procedure we are going to continue. What is the same procedure we are going to continue? That is P. Look at this PQ, QR, RS, SP. All the sections we will consider. So in each section we will consider it as a single current carrying conductor which is placed in the magnetic field. And one thing you have to note that all of you listen. One thing you have to note that. So this PQ and RS, PQ and RS sections, they are still perpendicular to that. Okay, sorry. So PQ and RS, they are still perpendicular to the field. I mean, in that, I think you have got that particular thing. So I'll show you this. This is the current carrying loop. And if it is like this, look at this. If it is like this one is making an angle 90 degree. This one is also making an angle degree. This one only makes a theta angle. Okay, like that. I think you can imagine that. And look at this. So force section on PQ. Let's consider PQ. So in two dimensionally we cannot show that. So when you look at this, okay, here it is also no. This n vector is just like this. Okay, n vector is just like this. Alright. So L is equal to minus AJ. So it is nothing but this is A and this side is B. So L is equal to minus AJ and B is equal to BI. B is always BI. Okay, that is from here to here. We consider this direction as I and this direction minus I cap. Okay, that we know. And also, what is F? FPQ, that is equal to I into L cross B. I into AB J cross I. So yesterday I have told you what is this? I cap, J cap, K cap. So what is J cross I? J cross I in the reverse direction. So this is in this direction, reverse direction. So minus K. So minus K minus got cancel. IAB cross A. Which means here n vector is in the direction of K cap. Okay. So that is what the indication that which we get from this. Okay. So force on section QR. So here where is QR? Here is QR. So L is equal to, this is also very important. You have to keep in your mind. So here theta is there. But as you understand, look at this. Here theta L should be equal to B into cos pi by 2 minus theta I minus B sin pi by 2 minus theta in K. So this is what is the equation. So B into cos pi by 2 minus theta I minus sin pi by 2 theta minus K. So that three-dimensionally it is very difficult to, two-dimensionally it is very difficult to understand. You try to follow one graph given in the particular in our textbook, that is check that and you will understand that. At least you have to understand that it is in the I direction. There is a component of this B because B is sliding. B is standing like this. Okay, so there will be a I component and there will be this component. K component. So both of them will make B. Okay, the orientation of B would be like this in a plane. Look at this. Both X plane and Z plane. Both X plane and Z plane. It is not residing just like this. It is just like this. There will be a X component over there. There will be a K component. Z component there. So B is similarly Bi. So only you have to understand this one and this one. Okay. All other things are pretty similar to last one. FQR is equal to IL cross B. IL be sin pi by 2 minus theta J, because this one and this one will be 0. When you take cross I cross sin 0, you will take this one and this one. So that will be J. Okay. That is I cross K. I cross K. So that will be 0. Okay. So again, I into L cross B minus ILB into sin J. So that is equal to ILB cos theta J. Okay, ILB into cos theta into J, because sin pi by 2 minus theta which is equal to cos theta. Again, the force on section RS. Next is RS. So RS is exactly similar to PQ. RS is similar to PQ. So again, the force on section RS is equal to L is equal to AJ, and then B is equal to BI. Take the cross product. This will be minus IAB K. Minus K. So here the direction will be minus K. So N vector will be in the direction of minus K. Here it will be J. Okay, minus J. I'm sorry. Okay. So then on section SP, similar to this. Here it is minus. So what will be the opposite direction? So as I told you, one is in QR will be residing like this, and then what about SP? SP will be the opposite direction. So I can say that. So it will be B cos pi by 2 plus theta into I sin pi by 2 plus theta K. One is minus and here is plus. The only difference. Okay. Oh, that is very obvious, because this one will be like this and this one will be the opposite in that direction. Okay. So and B is equal to Bi. Take the cross product. It will be ILB cos theta J. Okay. And what will be the net field? Net field will be FPQ plus FQR, FRS, FSB, and add all of them. So IABK minus IAB cos theta J, IABK dot K. So this one got cancelled, this one got cancelled. F net is equal to 0. Net force acting on that loop is equal to 0, as we have seen before. Okay. So then what about the torque that we will discuss? Okay.